In this video, we're going to continue topic 8.5, 5, 7, and 8. But we're going to work through example 6. But first, we're going to look in the left-hand column here. So there are times when they don't say perpendicular to the x-axis, they'll say perpendicular to the y-axis. So that's where we need to think about it a little bit differently. So we're going to talk about area first versus volume. So for area, when the equation is in terms of y, we're going to sketch the original equation, change all of the x's to y's and the y's to x's. And then we're going to find the area just like we did before. And then we're going to change the x's back to y's in your integral and write the answer and so on. So for the area in terms of y, never write steps 1 through 3 on your answer sheet. Just write the integral with y's on your answer sheet. So really what we're doing, I like to think of this, that's one way to think of it, is I always do right minus left. And then when we put it in our calculator, we only can use x's in our calculator. So we're going to use the x's. We're going to kind of use what it talks about right here, okay? But we only can write things down in terms of y. So in this case here, in example 6, let R be the region enclosed by the graphs of x equals negative y plus 9, which is graphed right here for us. And there's a typo right there, and the y-axis as shown in the figure above. Find the region of the area R. So what I don't know are these values here, so I'd have to find those. To get those, I would just do negative y plus 9, set it equal to 0, because that's the x value on my y-axis there. I would subtract my 9 to the other side. I double negative, it's going to go positive. Then I'd take my square root, which would be plus minus. So y equals plus or minus 3. So this is negative 3, and that's positive 3. So I know when I'm integrating, I'm going from negative 3 to positive 3. Then I know that I have to do the right minus the left. Well, in this case, the left is just 0. So my right is negative y squared plus 9. And then minus my left, which is 0 dx. I really don't need my left when I put this in the calculator. When I put this in, though, I'm just going to use an x there instead of a y. Okay, so I'm just going to put this in. I'm going to doc b what I've got, doc b. Okay, I'm just going to, since it's a simple one and I've already got my bounds, I'm just going to type it in here. So shift plus, and I know I'm going from negative 3 to 3. And then my equation was negative y squared plus 9. Actually, I could put this in my calculator the way it looks, as long as I'm not doing it in my graph. So let's try that. Negative y squared plus 9. And then since my variable of integration is y, instead of putting an x here, I would put a y and hit enter. So that worked. I'm going to do the same one again. I'm just going to copy this. And instead of using y's, I'm going to use x's, just so you can see that it doesn't matter what variable is there. So look, I could do it again. Let's say I use a's instead. It doesn't really matter the variable. If I was putting something here in my graph, it has to be x's going from that one. So I would just say that this is equal to 36.